All right, so the components of a geothermal system. The main components of a geothermal system are the ground loop itself. Then we have our heat exchanger inside the system. Technically, we have kind of two, you could say. And then, so that's within our geothermal unit, as we refer to it, since we're doing both heating and cooling from a system that's going to go inside. We call that a unit. And then we also have our domestic hot water heating system as well. So we're going to we can do that with hydronic heating, or we can do that with forced air as well. So
Kyle, could you speak a little bit more to the refrigerant in the loop, what kind it is, if there's any innovative refrigerants being used, especially in the context of the refrigerant management credit from the new V4.1 system?
Yeah, forgive me, sorry. It's not typically a conversation that we have a lot of, but we use all R410A now. No one uses R22 anymore, and that was the refrigerant of the past. It was actually very efficient refrigerant, however, not environmentally friendly. So now we try to stick to the path of what everyone in the industry is using as much as we can, which is for now our 410A, which is included in that list. And in the future, that's probably not going to be the case. All manufacturers will go to a more efficient refrigerant, and there's quite a list of those what could be used out there in the future. But our theory is stick to what the masses are doing for the ease of use of the contractor themselves doing the work and for the consumer, so that if they were to have issues, and I mean these things are mechanical, they do break down, when there is an issue, that they easily have that refrigerant accessible to the servicing contractor that's already probably on the truck. So that's our theory, and in the future, though, we do plan to investigate, or we are investigating, rather, other refrigerant types to be more efficient, so when that time does come when multiple manufacturers are using the more advanced types of refrigerant, we'll get to that point and we'll be ready to go. All right, so the geothermal system in the heating mode. So our ground loop is the starting point. Whenever we have our heat exchanger and the refrigerant and the water with antifreeze mixed, they never touch, ever. They're just it depends on the type of heat exchanger it is, but basically what we're doing is we're mixing the refrigerant and the water temperature to extract or dump heat into down into the earth. So in this slide, we're actually illustrating how we're doing that. And so the compressor is actually increasing the temperature of the gas and then sending that across in this case, it would be a forced air coil, and sending that into the home itself, and then cycling, bringing that back to constantly extract heat out of the ground and bring that up to the facility itself. Cooling mode, it's all the same equipment, it just reverses, and we do the opposite. So we're taking the heat out of the building and we're dumping it down back into the ground. So if you ever, on a simple side, something we talk to consumers about, is if you ever sit at a refrigerator, which we all kind of do, and we're looking for something to eat, well, we open the door, it's cold, but at our feet, it's always really warm. And that's exactly how an air conditioning unit works, as well as geothermal heat pump, or a ground source heat pump, as I should say, work the same way. So we're extracting the heat out of the space, and we're dumping it down into the ground. So we have a huge benefit on our side, on the geothermal side, for domestic hot water heating throughout the cooling months, definitely the cooling months, and some in the winter months. That is what we call a superheater, and what we are doing is basically we're heating up we're extracting the heat from the house or the facility, and then before we take that heat and dump it down in the ground to get rid of it, we're actually taking that waste, if you will, that hot waste refrigerant, and we're circulating that with the tank that is actually sitting next to the geothermal unit. That can be done in a variety of ways. The most inefficient way is with one hot water heater tank. Then you actually, to be more efficient, like I have in my house personally, I have my geothermal unit that circulates that desuperheater pump through a hot water heater that it matches my hot water heater, but it's just turned off. So it's what we call our storage tank, and our raw water comes into that tank. And whenever we take a shower or the washing machine runs or whatever, it actually sucks the hot energy from the hot water heater, and then it's replaced from the storage tank that has had time to circulate with a unit to replace it. So that basically what I'm saying is that whenever the hot water heater is fed hot water, it's already preheated. It's already probably upwards of 115, 120 degrees sitting there in that tank to be able to feed your hot water heater, so that it has to do minimal heating of the water to get it that domestic hot water up to temp. So that's what we call the superheater function, but we can do more than that. I'll get to those shortly here when we talk about pools a little bit as well. So a ground loop piping. We expect way more than our lifetime, more like an alligator, 200-year life expectancy or more out of a ground loop. Since we're using that polyethylene HDPE pipe, it's expected to last a very long time. This image here on the right was actually a job that we did here local as well, that was actually at one of my friend's business, and we hit groundwater at his at a very low point. So he wasn't happy because it affected his price of his sewer system going in for having a high water table. However, he's a happy camper now because how efficient his geothermal system is every month because he hit that high water table. So a typical application for a geothermal system is pretty standard forced air. At this point, we have to do all of our cooling through forced air to dehumidify. At some point, though, we do want to get into, our plans are to do radiant cooling as well, and that would not be through the floor. That would be actually through ceiling panels. The typical application nowadays that we sell the most of is forced air, where we'll have what we call a package unit that will do both our heating and our cooling with the heat pump section on the bottom, and then the top part is actually your air handling section. So if you look at it from an efficiency perspective, we have a very, very small space for the refrigerant to travel through when they're packaged together. So package units are a very easy system to install and have a very good performance out of. So what we have in this case is the components are, we have our ground loop going out of the wall here. We have our pumping box, which we call a flow center, that circulates the loop through the bottom of the unit in our heat exchanger. We have a hose kit. So we have plastic rigid pipe here, and then our hose kit is a rubber pipe, which would decouple the unit itself from the rigid pipe or the wall, so that we don't have any vibrations or any sound traveling into the house. And then also we have our flex duct here, which also decouples the system as well as an air pad. So by taking all of these functions together, we're actually able to produce padding from the system, and that way we don't have any vibrations, which leads to noise that would affect the comfort noise levels of a home, and you still achieve getting the system, that compressor inside of the house. So, and then the other part of the component, last component that I forgot to mention, is our auxiliary heat. And there is a huge misconception with geothermal and air source heat pumps that you have to have an auxiliary heat strip with geothermal, a backup heating element, because it can't get down to certain temperatures. Well, I'll tell you that that is most certainly wrong with geothermal. And that auxiliary heat strip is only used if, as a backup, if the geothermal unit itself were to break down. In some design applications, we do have a balance point where we'll design down to a certain exterior temperature, but that would be at a very low level and would be designed into the system itself.
Kyle, on that backup heating system, I'm just thinking there was 2 LEED gold multifamily projects built exactly the same, right next to each other at the same time. One with natural gas, the other with geo, and thankfully they were doing research on which one was more efficient, and we're finding that the geo was using way more energy, and then they kind of found out that the backup resistance heaters were just running all the time when there was no way to stop them. Is that a problem, or has that been, this was a while ago, so has that been, so if people do have it, is it easier to determine that those things are running or not running?
Well, yeah, I mean, there's monitors to see if they are running or not. Usually a consumer is going to let us know if they are running because they're going to freak out over their bill, their electric bill. But that issue would have to have been either a sizing issue or an installation issue as well if that auxiliary heat strip was to be running. They are only to be used in extreme situations or as a backup. So in your study here, somebody was not fair to the geothermal side on the installation or the sizing of that system. In order for those to be running, there has to be a major problem.
Yeah, and once they found it and they shut it off, then it flipped the other way. So.
Yeah. Hey, on my house, for example, I just turned it off at the breaker and never let it run. It never needs to come on. And the only reason I'm going to use it is for if I lose something and were to break down inside the geothermal unit itself, it would be a backup mechanism to run the blower section across that auxiliary coil to get heat into the house until we can fix it the next day. So but I will take that opportunity though to say that we can merge the two. So you can have a hybrid geothermal system as well. In this slide, we would actually decouple this heat pump section on the bottom from the air handling section here, and then we would use a furnace. So we could use a furnace to do either LP or natural gas as our backup, and you can even select a balance point to the design of the system to where if you wanted, for example, at 20 degrees Fahrenheit, you wanted the gas side to kick on, absolutely. We can do that, no problem. If you're going to have gas in the house anyways, for example, a range or a cooktop or a gas fireplace or whatever it might be, personally, I would suggest utilizing it and hook it into your heating cooling system as well. And you have then a redundant system if you were to have any issues, or if gas prices are really cheap, which they are today. They won't be, we can't guarantee that next year, but whatever. You have some variability there. You can switch between either or.